Do I want to do it this way? Maybe I'll do it this way. 36 plus. Do you guys get 43 for number one?
Yeah.
43, I think, is right. 43. Number two, I think, would be negative 15x squared plus... Oops. Negative 15x squared plus 3x minus 18 minus 4x squared plus 28x. So I'm coming up with negative 19x squared plus 31x minus 18. Let's take a look at numbers 1 and 2. I didn't show any work for number 1. I saw a lot of 43s out there. So I'm wondering if anybody has any questions on 1 or 2. Okay, so then number 3, doing a little bit of simplifying, you would get this and that, and it would be 7x is less than or equal to negative 14. Do you all get x is less than or equal to negative 2?
Yeah. Yes, sir.
Okay.
Yes.
So then if this is 0, that's negative 2. Filled in circle,
Yep.
arrow left. What do you guys think of number 3? Any questions, any kind, concerns about number 3? You guys doing okay? Yes, sir.
Was the intro video due to blindness?
Don't worry about it. We'll talk about that in a second. Number 4 then. Number 4 is probably the one that has the most complex stuff going on. We're supposed to, kind of like yesterday, we're supposed to find the equation of the line that is perpendicular to this other one. So let me remind you, what are the 2 things you got to have to write the graph or equation of any line? Point on the line and the slope. Okay, so, and we'll get to that in a second. Yep, for sure. So of those 2 things, we have what? Not directly. We definitely directly have the point. It's negative 9.7 lies on our line. We sort of have the slope, but we got to do a little work to get there. Our line is perpendicular to this other one. What's the relationship between parallel line slopes, or perpendicular line slopes? Opposite and reciprocal. That's right. So what's the slope of this current line? That's right here, isn't it? Negative 3/7. So what's the opposite and reciprocal of that? 7/3 is correct. Okay, so there's my slope. There's my point. I just need to put this into slope-intercept form. To do that, I'm going to start off with point-slope form. So it would be y minus 7 equals 7/3 times x minus negative 9. Of course, that's really plus 9. And then do you guys do a distributive property to get this going?
Yeah.
Okay. So when you distribute the 7/3, you get y minus 7 equals 7/3 x. And then 7/3 times 9 would be 63/3. And 63/3 is really 21, isn't it?
Yep.
So when I add the 7 over, I end up with y equals 7/3 x plus 21 plus 7, so plus 28 for a final slope-intercept equation of the line. Okay, so you've seen those 4 questions. You can see them up there. Knowing that you've got a quiz on that stuff tomorrow, how you feeling? Any questions?
No, you should know this by now.
Very nice.
Anything at all? Any questions, Jaden? Okay. You guys doing okay? Solid? All right. So here is my hope, really honestly, in the most sincere possible spirit. I really hope that tomorrow you start your semester off with a good 4 out of 4. Nail your DMR quiz, 100%. Start off. Everybody likes to say that just... You guys, listen, you guys know better than this. Everybody likes to say that, hey, you start off the semester with 100%. You don't. You start off the semester with this. 0 out of... No, you don't start off the semester with a 0 either. You start off the semester with a 0 out of 0, and that's undefined. Right now, your grade simply does not exist. As of tomorrow, it will. So I hope that it starts off with a good instead of 0 out of 0, how about a 4 out of 4? That's my hope. I hope that you do the same thing. Listen, what could you do to help yourself? You could go back, especially, I am a fan of being honest with yourself. I hope you are too. If you did these 2 DMRs and maybe in both cases you missed number 4 or you missed number 3 or maybe you missed number 2 one time or something, you could really help yourself by going back and practicing those. You got your notes right there. I'd go back and re-practice and notice all the things you need to notice so that hopefully tomorrow you do get that 4 out of 4. Something to think about. Last chance to ask questions. Fantastic.
Nada.
Okay, so yesterday we looked at square roots, and the unique thing about yesterday is all of the square roots that we looked at yesterday, the radicands were what we call perfect squares. Maybe you noticed there was a bunch of 16s, and I didn't just pick 121 randomly, right? There was 81s and 25s and 49s and all these numbers that, wow, look, they have these perfect square results, right? Because 7 times 7 is 49, and 4 times 4 is 16, et cetera, et cetera. So the question becomes, what if you have a radicand that is not a perfect square? What do you do with that? So one of two things. You could approximate it with a calculator, and at times we will do that. Or it could be reduced to a simpler form, and we will use factor trees. Factor trees to help us reduce square roots. Are you guys all familiar with that? Factor trees? Trying to get down to prime factors with those. There are other ways to do this. Fully acknowledge that. This is one. Okay. So if you take a look at an example like number 1, I want to teach you a couple of these, and I'll have you guys work through the other examples. Just see how it goes. So number 1, did you notice that the radicand is not a perfect square? 12. Like there is no whole number where if you multiply it by itself, you get 12, right? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. We just jumped right over 12, didn't we? 12 is not a perfect square. So here's what we do. I am going to take the 12. I usually will do this off to the side somewhere. Bless you. And I am going to break the 12 down into its prime factors. The way I could do that is with a factor tree. So the way we do this is we ask ourselves, what number times what other number is 12?
3 and 4.
2 times 6 or 3 times 4. Either one will work. It really doesn't matter what you pick. I'll go with 2 times 6 since she said that first. Once you've broken this down into, hey, what times what is 12, you want to ask yourself, are either of those two numbers prime? 2 or 6? Are either of those a prime number? 2 is prime, right? Because the only numbers that go into 2 are 1 in itself. So 2 is prime, so that branch of the tree is done. 6, however, is not prime. What times what is 6? 3 times 2, or 2 times 3. Okay, so then again, you're going to ask yourself, are either of those numbers prime? Aren't they both prime? 2 and 3 are both prime. So 2 and 3 are prime. Since I've gotten all the way down to only primes, then I know I'm done with my factor tree. I know then that 2 times 2 times 3 is the same thing as 12. So what I'm going to do over here is rewrite my square root of 12. And instead of square root of 12, I'll write square root of 2 times 2 times 3. So there are all kinds of ways to approach it from here. And I can kind of help you explore a number of them. Here's one of them. Here's one way. Once you've done your prime factors, if you're doing a square root, you want to look through the prime factors and ask yourself, are there any pairs of like factors? And do you see how there's 2 2s? Okay. So when you see those 2 2s sitting right there, you know that those are going to simplify. If there's 2 2s inside the radical, it's going to simplify to be a single 2 on the outside. So this would simplify to be 2 square root of 3. Okay, so let me explain a little bit more about why that is, okay? Somebody could question that. It's just sort of a trick way to do it, and I'd hope that eventually you'd get there. But here's why. What's 2 times 2?
4.
So this is really square root of 4 times square root of 3. And what's the square root of 4? 2 root 3. Does that make sense? To me, the faster way is simply to look through this and recognize that there are 2 2s. 2 2s inside the radical is equivalent to 1, 2 on the outside. So it'd be 2 square root of 3. The reasoning is simply you're just doing the square root of 2 2's, and you get 2. That'd be just kind of a trick way to do that. So let's see here. Why don't you guys do a little exploring with number 2? Can you guys try to do the prime factors of 200? It's a much bigger number than 12, right? So this might take you a little while. See if you can break 200 down into its prime factors using a factor tree, kind of like we just did. So far, so good. You actually could use that. Seems more difficult, but they're really not. It's actually in some ways a little bit easier. Remember yesterday we talked about this. Isn't x cubed the exact same thing as x times x times x? So you've broken that down into its prime factors as well if you did that. So take a minute. If you didn't do anything with the x's yet, that's okay. I'll ask you to deal with the 200. Go ahead and deal with the x's as well. I would rewrite those as x times x times x. At this point, once you've gotten to here, you've got prime factors, all prime factors. Please ask me a question if you've got one. If something, maybe the x's thing doesn't make sense, or yeah, Chase. Oh, sorry. My bad. I thought maybe it was a good presentation.
No, I just have a pair. So
Yeah.
when you're doing x times x, if you have a pair, I know you have the pair.
You do have a pair. Mm-hmm.
So if you have the 2x or 3x's, that's a pair.
Yep.
And what do you do with the second one or the last
It has
one?
to stay inside.
So do you make that x the second, or do you make that 2x?
So these two x's right here, they come out of the radical as just a single x.
So it's just x.
But these two that came out as a single x, there would be an x right there.
Oh, it's
10x. And then inside would be
just 2x.
2x.
Okay, so if you pair anything, it all has to be outside.
If you pair anything, it comes out as a single.
And you just multiply.
And you multiply the stuff that comes out. Yep, true. Very true.
Okay, so it's 10x.
Okay, so here we go. Here's how we would finish this. Did you guys notice that there is a pair of 2's in the radical? Did you also know how there's an extra 2? That extra 2 is going to have to stay inside the radical. Did you also know how there's a pair of 5's? Pair of 5's, so the two like factors, right? And then also there is another pair. It's a pair of x's. So we actually have 3 pairs of like factors. And if you've got pairs of like factors, they come out as a single version of that pair. So these 2's would come out as a single 2 times the 2 5's would come out as a single 5. And the 2 x's would come out as a single x. Inside the radical, you do have some leftovers. The 2 and the x. Okay? What do you think? Any questions? Now, 2 times 5 is 10, so it'd be 10x times the square root of 2x. But that's, obviously, you guys can do 2 times 5, obviously. I just want to make sure you understood the radical part. Questions? We're going to do some more practicing here, but at this stage, knowing that you got some more practicing, is there any conceptual stuff here? Okay. Well, then, let's see how you do. Feel free to work with a partner or on your own. See if you can handle number 1. Yes. Numero uno. I think there's just going to be one thing we need to deal with. I noticed you guys are doing a really great job with your prime factors. So 20 would look like this. It would be 2 times 2 times 5. And then x to the 5th would be times x, there's 3 of them, 4 of them, 5 of them. Making sense? Okay, so what you're doing now is you're looking for pairs of like factors. So there's 2 2's. Poor 5, nobody to go with, so 5 is stuck in the radical. But there's a pair of x's right there and a pair of x's right here. This is, so walking around, make sure you're paying attention here. Walking around, the vast majority of you, if not all of you, got to this point really well. Quite quickly, too, so that's great. There was a little mistake that was made by some folks here. The 2 2's, right? There's a pair of 2's. They come out as a single 2, right? So the 2's hanging out here. And then I've got this pair of x's. Doesn't the pair of x's come out as just a single x? So times x. And then this, so I've done this one and this one. I've got that last pair of x's, right? Would come out as another single x. So times x. The radical, still going to have the 5 in there. And then this extra x would be in there as well. Here's where the mistake was made. It was made, at least that I saw, right here with these two x's. What is x times x? It's x squared. It's x squared. And so the finish here would be 2x squared root 5x. If I've got a pair of x's and I want the result to be 2x, what do I do with the two x's? I've got just an x and an x hanging out there, and I want to end up with 2x. Do I multiply, subtract, add, or divide? Add. X plus x is 2x, x times x is x. Okay. Any follow-up questions on number 1 there? Okay, so I've seen you guys have started to work your way into number 2. If you haven't already, go ahead and please try number 2. Prime factors are just 3 3s, right? So this would be 4 times the square root of 3 times 3 times 3 times m. And again, because it's a square root, we're looking for pairs. And hopefully you saw that there was a pair of 3s. And that's it, right? Yeah. So the two 3s come out as just a single 3. So it would be 4, which was there to begin with, times that single 3 that came out, times the square root of 3m, maybe a final answer of 12 times the square root of 3m. Final expression there. So I saw a lot of those, a lot of that correct answer out there. Do you have any questions? Okay, so then number 3, kind of let you hang with that. It's a little bit tougher, obviously. It's a fraction. I'm going to let you just kind of explore and discuss. You guys are doing a great job already. See if you can come to a conclusion, and I'll certainly show you a solution to it here in a couple of minutes. Ready to go. It's tough? Kind of? Sort of? Let's find out. Here would be my suggestion to you. We talked about this briefly yesterday. You might have forgot it because we did just talk about it yesterday. When you have the square root of a fraction, you can treat them as 2 separate square roots. So that would maybe be my first step, is I would rewrite this a little bit. I'd rewrite it as the square root of 72x to the 8th divided by the square root of 25. The reason why I would do that is because right away I can see that the square root of 25 is 5, right? It's going to make that denominator much easier to handle. So I would suggest that I unfreeze this first. And there we go. I would suggest you rewrite it like that so that you can clearly see numerator and denominator. And in this case, denominator significantly easier than numerator. Make sense? And I saw a lot of folks did this really well. They used their factor trees and they said that 72 is really 3 2s and 2 3s. Correct? And then x to the 8th is just 8 x's. So 2, 3, 4, 5, 6, 7, 8. Hey, have you guys figured out, maybe you probably have you guys figured out the pattern here that, like if there's 8 x's, 4 of them come out? If there's 400 x's, how many of them come out? 200, right? So you don't have to, obviously, if it was x to the 400, I really wouldn't expect you to write out 400 x's and circle up 200 pairs of them. I'd hope that after a while you'd see that pattern and be like, oh my gosh, if it's x to the 400th, the square root of that is just x to the 200th, right? There's 200 pairs of 2s in 402. So anyway, so you got some pairs here. You got 2 2s, you got 2 3s, and you got a bunch of pairs of x's, in fact, 4 of them. So in the numerator, let's see, we'd have a 2 that came out. We'd have a 3 that came out. We'd have 4 x's that came out. What's the lone leftover inside the radical? A poor number 2 got stuck in the radical. So sad. And the 5, of course, is down there in the denominator. So maybe a final answer of 6x to the 4th root 2 over 5.
I got it the first time.
Oh, over 5?
Over 5, yep. The 5 is in the denominator, so it should stay down there in the denominator. Did you move it up?
No, I had it in the rack.
Oh, yeah. So the square root of 25 is just 5. It's not square root of 5. That make sense? So that's where if you split it up like this at the start, you probably keep those two straight. Hey, guys, any questions or concerns of any kind? Okay, let's see. I would like to get a bird's eye view of how you're doing. So if you would, we're going to go to the board. I don't know. I don't think there's any way that you all fit up there at the same time. There's just too many of you. So let's start off with Callie's table and Aiden's table today. Why don't you guys head up to the board?
Cool kids.
Please. You can erase everything that's up there. And you guys can use the backboards too. That's fine.
Oh yeah, everyone looked like kindergarten.
Ready, go. Please simplify the square root.
No.
98 is an even number, so 2 has to go into it.
Yeah, I got my goals for divisibility in school.
How do you know the numbers?
I never
Add up all the digits, and if the result is
I never learned that.
Oh yeah, you just add the two numbers together and then.
divisibility by 5 is standard. 5 to 0. That's pretty handy when you do the back and forth.
Yeah.
Out of the box, the weird weedy loop, the circle, and then nothing.
Totally too
So the correct answer to this one is 7 root 2. 7 times the square root of 2. Okay, let's try another one. Everybody stay at the board. We'll switch in a second. Try number 2. The square root of 180.
Boy, you.
Josh, it's 92. You're dying with like eggs.
Deal with it. What do you want me to go like that?
What? Shoot.
You know what, women? Shut your mouth.
Whoa! I know.
Yeah, it is. Yosh the gent. Me too.
No, you don't.
I was always in the back.
Callie did it wrong too. Wait. You get 12. Josh. It's everything number. I do one. Wait, 1, 2.
Okay, the answer is 6 root 5. 6 root 5. Hey, let's switch. If you're at the board, sit. If you're sitting, get to the board. Okay, please try number 3. Square root of 147. Square root of 147. 2 and 10.
Chase, your slush is staying.
Callie, what are you doing? What goes in the hole?
She needs the extra packet.
Anybody know this? No. 2 and 10 is not. Stop
Is that your
it.
answer to 71? No, it's not.
Somebody asked for the life advice.
You told me. Yeah, it's wrong. It's wrong. It's wrong. That would be 142. 143 and a half. It's 143 and a half. It's 73 and a half.
What did you just draw?
It's 73.
7 and 21. 7 and 21.
Are you trying to write the tiniest?
I don't know. Okay, you know, I'm like, oh, actually, I got it.
7 times 20.
Oh, yeah.
2 and 10 boys.
Why do you have a C?
There's a C.
It's a C.
It just came to you? What it is, I think you're 7 times 20.
Just as beautiful.
Right? 7 times 2 is 14.
I love you. You should enter
And
context.
7 times 1 is 7, right? So
Good work,
only one.
Brian.
I don't want to.
Font.
What?
Like computer fonts?
Wait, I'm proud of you.
Yeah, you know what? Let's go with me. I'm gonna go with me.
I'm proud of you too. Good work. What is that hustle?
Like you're slowly growing fonts.
No, too much
I am
fun.
Actual documents.
Especially the secret.
Ava,
We figured it out.
She creates fonts.
Okay, so 147 was kind of tough, wasn't it?
See about that?
Hey, hey guys, listen up. So I was talking with these folks back here a little while ago about how do you know what goes into what. So this would actually be a pretty handy situation. 147, it might not look like it, but it's divisible by 3. Here's how you know. Here's your divisibility rule for 3. If you take the digits and you add them up, so 1 plus 4 plus 7 equals 12. If the result of that is divisible by 3, then 147 is divisible by 3. So there's several of those divisibility rules that you hopefully saw in middle school. Be very handy. Okay, so this ended up being 7 root 3. We're good. All right, let's do another one. Number 4.
Oh no!
What'd you say? What'd you say after this class?
Okay, square root of 216. Ready to go. If it's an even number, you got to go with 2, don't you? Well, you don't have to, but I think that's the most logical thing. It's even, just keep dividing by 2 until it's not even, and then move away to 3. It's just a matter of that way you know.
Hey, stop copying equipment. Okay, yes, you can. Jaden, you're a smart man. Let's go.
Nice.
Hurry.
Are you giving yourself a headache?
So much. Oh my God.
That's really nice.
Okay. Women, I like that.
See how I write my G's?
Your nine looks like A. Everything looks like an A. Everything in his handwriting looks like an A. And then write your 9. Got it. Yeah. Your 9 is an A. Right?
Or like the little
In
Josh is like, she's an entire paragraph and it's all A's that look just slightly different.
I got it wrong.
Yeah, I mean, like sometimes it's only 2 too.
Larry. I got, okay, so I have.
Oh, yeah,
and I was
he's
wrong.
right.
So it's 17 and we had 12.
I forgot that she's different types of A's.
That's what I tell you. I said they don't know.
I'll get it. Callie's name. I said it was an accent. Put an accent mark over her name.
Yeah.
Holly.
Holly. That's somebody built my gun. Okay.
Don't use the word. Okay, I got called my last name wrong.
Did you take my gun?
Yeah, it's like we're EA.
Okay, Siri autocorrect. How did that end up like there? I forgot what, like Ava? Yeah, it was like what was it? Shoot.
Still gotta watch that.
I'm sorry, darn it, I forgot it.
You're dead.
Yeah, he's mine, so just, that's your
No,
grandpa.
it's just like,
Oh, yeah.
Oh my gosh. I was ready.
Don't go.
I texted my friend to.
So I'm gonna talk to your grandpa like that. He's old, okay? He can't do much about it.
Okay, let's do another switcheroo.
oh my god.
Okay, ready to go. Please simplify that.
Stop with your 2 and 10.
What is that number?
So basically, after me and you were like trash.
How did Callie get that before us?
Shut up, Callie.
Callie,
Unacceptable.
Graham.
Callie, you and me actually disagree.
I got the answer, kid. What? How did you get that? That was for you, Nick.
Was it Y?
It's a Y. Yeah, it's a Y. It's a Y. Callie and Aiden, you're wrong. You're wrong. How did I get that?
I just said
Koi is moist.
No, that's what. Koi. Are we wrong? No, we're right. 2 times 2 is technically 4. This is just a coin. I did the same thing. Yeah, no, we can get it.
No, I went with our shares done, so I think it's kind of
So if you were gonna take a good one today,
Koi? Did they sort you guys out?
Yeah.
2 white squares?
Yeah. I need yellow.
Cool. This is good. Let's do one more.
I need to finish it. There's a different
Yeah.
Who drew that face?
Yeah, he never had a
That's
shoe.
Why is
Boy.
it?
No, I got really good.
It's 137.
You just erased your
Or no, no, no.
Yeah, it's gonna be like.
Kelly, I erased it. I made the boy.
Ready, go.
What?
It's 2 and 10.
This time it's 10 and 2 this time.
All right.
Oh yeah, no, Kelly, it's. Three.
Is that gonna sound
Really?
75 what's your head?
The tough one, I think you guys should like picture. Do I know how to do
I don't understand.
Wait, what's 5
What?
times 25?
It's 9 times 23. 9 times 25.
Well, don't do those yet. That's just.
Or that. How goes in 5 and 2?
You guys are gonna be doing the same kind of questions this morning. Do great. Feel free to look around and your friends and see if you You guys agree, but you guys disagree.
Participation trophy.
Yes! Oh, it is that. No, our team won the championships and our trophies said good participation.
And this is a board.
No, I did not.
Trash.
We were undefeated. No, that is the championship. Back-to-back games and our trophies said good participation.
In basketball.
You get a gold medal.
Wait, but what was
Sick nasty. That's rude.
If you got a copy.
She was drunk.
2. All right.
I got it like 6 for a girl and a 4 for a girl. Ben, that one was for you.
Well, you know what?
He doesn't need
Go back up to you guys.
Hey.
Unfortunately, not 225, it should be 9.
I'm trying to balance. It's harder than you think.
Kelly's like, it's my
We'll change your answer.
That's not a 5. Like right here.
Actually,
That's not a 5. Okay,
Oh my
this
God,
is.
his face is learning.
There's a guy.
But it's a hard.
There's a guy. You eat a burger. You eat a patty. That's coffee. And then he cut up what's called like the burger patty, and then eat that first. And then eat coffee, and then you make bread.
Kelly, it's your below mine.
Yeah, oh yeah. You can.
No, yes you can. Son, I won't take you out here. I'm not taking you out.
take a look at what, hey, Coy, did you scooch, David, did you scooch? Look at what Coy has up there.
Is that a monkey?
Look at his answer.
I like the way he's made.
It's a unicorn.
You're like almost in the should be.
No, this is my universe number. How about
What?
Callie? There's
The biggest thing you guys got for
Oh,
Ben. You remember Ben Carter?
you guys is
4, 1, 5, 9.
Ben Carter.
I get 2 pairs of
Oh, that's so high.
Yeah, yes, Jaden. We brought out one end. We brought out the like you said earlier, 5 times 3.
Oh, yeah.
Hey, let's shred you.
Good. I don't like people going with
Hey guys, we're switching, so if you've been sitting, you're up. If you've been up, you're sitting, okay? Switch. So Mariah's table should be up, and Chase and Ben and Nick. So 216 is 108 times 2. So start, I'll go to the board. We'll get this figured out.
I was trying to do not erase it, but you erased it. As your
Okay, ready, go. Square root of 32, x to the 5th.
16 times 2. Callie. You're welcome. Chase, hustle.
He sounds like a therapist.
Yeah.
Tell me how you're telling me feel.
Harry, you're cheating. No, I'm not. Callie.
Chase, you got it, you're good.
She's getting lazy.
Ben, good job.
Thank you.
You guys are welcome to pack up and go. I know we're up against our time. Have a great day.
My pencil gun broke.
Yeah, you're good.
Is that right?
Dang it.
Ben, we have web design. I get to go make my
Let's get our web design on.
Ben, let's go get it.
Let's get our web design on.
Good job, Nick. Great job.
Oh.
They got it. But I'm also singing along.
Let's go.
Boy,
What?
I have to tell you something. Chase, we gotta get our web design on.
Yeah.
Oh.
Oh my god. Okay, wait.
How you doing?
I can't for 3 weeks.
That's too bad, dude. I got a really good smile. Last night I got